Hi everyone, it's Miss Huang here. We're going to go over kinematic equations and problem solving. So I'm going to go over the equations and how we're going to apply them into the questions, because a lot of you have been having a little bit problems or getting stuck on how to apply the questions. So I'm just going to go over it with a video and go over the equations as well. So D in this equation here stands for displacement or distance, depending on what the question is asking for. Then we have the initial velocity, VI here, so this stands for initial, so it's the first velocity that is given. Usually it is 0 meters per second or whatever the car is already at its motion, and sometimes the final velocity is at 0, depending if the car is decelerating or not accelerating. Then we have T here, that stands for time. I can write down a few of what they stand for here. So this one's initial velocity. This one is distance / displacement. But if you're working with velocity, you're most likely going to be working with displacement. If you're working with speeds, then you're working with distance. Time is for T. Then we have a 0.5 here in the formula. And then we have acceleration. So A stands for acceleration of the object, and again T for time. Okay, and then it is square rooted. In this equation below, it's also final velocity. Okay, that the subscript is the F for final, and again here is initial velocity. So the I is the subscript for initial, and then you have 2 multiplied to acceleration multiplied to displacement, since we're using velocity. Displacement. And then in the next formula, we have final velocity. And notice how this one is not squared. This is initial velocity. Acceleration. And time. This equation is actually rearranged and found like this in your formula worksheet, but they're both the same. It just depends on which value you're looking for. So sometimes you're given variables that you need to look for acceleration, compared to sometimes you're given all the variables and you want to solve for final velocity. So then you rearrange your formula and you would use this one instead of this one, depending on which one you're looking for. Next, equation that doesn't use acceleration at all. We have the displacement or distance given displacement. Then we have the initial velocity. We also have the final velocity. Again, the subscripts are for final and initial. And we have it with time. Okay, now let's see these formulas come up. How are we going to use them? So there is a strategy that you can use. So I'm going to zoom out here and we're going to write down a few problem solving strategies, okay? So here are some steps that you can use to help you solve these questions. So 1, construct an informative diagram of the question. So sometimes you'll get a question that goes, Tom walked 5 meters east and then walked 2 meters north. Where is his final displacement, or what's the magnitude of his final displacement? Always draw it out and it'll help you in the long run. Same with if a car is moving so forth this fast, draw it out, it'll help you. Number 2, identify and list the given info in variable form. So I already said this several times during the examples. So what you want to do is you want to identify it from the question. So a question will be going, Tom accelerated 2.65 meters per second squared. You got to identify that Tom accelerated, so A equals 2.65 meters squared. That you know is acceleration. So then later on when you're looking for which formula to use, you know which variables you have to insert into those formulas, and then therefore it'll like filter out which formulas you can use. Number 3, you must identify and list the unknown information. So it's very important to also list your unknown. The question will also tell you what is unknown. So maybe the answer, or what they want the answer to be, is what is your final displacement? That means you're looking for D. So that means you need a formula that has a D in it to be able to use, okay? To plug in all those numbers to solve for D. And then step number 4, you want to identify and list the equation that will be used to determine unknown information from known information. Okay, so that's a big one there. You want to list out the equation first, and then you want to see if your unknown variables and known variables can actually fit into that formula that you chose to use. Step number 5, substitute known variable or known values into the equation and use the correct algebraic steps to solve for the unknown. Okay, and lastly, the 6th one, check your answer to make sure it's reasonable and correct math way. Okay, so number 6, if you solve a question using digits and values of 1s and 10s, and you all of a sudden get an answer in the thousands, does that make sense to you? No, most likely it's incorrect. So you want to make sure your value makes sense too, your answer compared to the question. Okay, so we're going to go over some problems using the step-by-step measures that I listed out here. So 1, 2, 3, 4, 5. And hopefully you can also apply the same steps to your own questions so that it makes more sense. So example 1. Tom is approaching a stoplight moving with a velocity of 30 meters per second. The light turns yellow and Tom applies the brakes and skids to a stop. If Tom's acceleration is -8 meters per second, squared, then determine the displacement of the car during the skidding process. Note that the direction of the velocity and the acceleration vectors are denoted by a plus and a minus sign. So again, the acceleration here for Tom is minus 8 meters per second because he's slowing down. That's why it's a minus, okay? So let's go over the solution. So the solution to this problem begins by making a diagram. So we're going to apply step number 1 and make a diagram. Okay, so I'm going to draw a car. It will be a it'll look like a sombrero, but it's a car. The acceleration is minus 8.0 meters per second. Okay, the initial velocity we know is 30 meters per second. The final velocity is 0 meters per second because he skidded to a stop. And then D equals 0. Okay, so this is a picture of the car slowing down, so it's moving, and then all of a sudden it has stopped, okay? Now, once we draw the picture, we notice that the next strategy is listing the unknown desired variables. So I listed all the variables that are known, that acceleration is minus 8 meters per second squared, that the initial velocity is 30, and that the final velocity is 0. So what is the unknown? So we are finding D equals question mark, because the question is asking for determine the displacement of the car during the skidding process. So we're looking for D. So the next step that we're going to do is identify that kinematic equation that will allow you to determine the unknown quality. So there are 4 equations to choose from, and we know, okay, that we have one unknown variable, which is D, and we do have variables A, VI, and VF. So let's go back to our equations and see which one is better suited for that question. So we know we cannot use an equation with time because we did not get time. So that cancels out this one, and this one. So we can use this one. Okay, so we're using VF squared equals VI squared plus 2 times acceleration and displacement. So we're going back to our question, and we have decided our formula that we will use is VF squared equals VI squared plus 2AD. Okay, once the equation is identified and you have written it down, the next step is to substitute the known values into the equation and use proper algebraic steps to solve for the unknown information. This step I am going to go through with you, so we're going to plug in all the information into. So 0 meters per second is the final velocity, but it's squared, equals 30 meters per second, also squared, and then plus 2, and the acceleration is negative 8 meters per squared, multiplied by the D here. I'm going to shuffle over so I have enough room. So this is 0 meters squared over s squared because this multiplies over, and then equals 900 meters squared over squared plus negative 16 meters per second squared times D. So we multiplied these two numbers and that's how we got negative 16. And now we're going to keep isolating it over. So we're going to move the 900 over to this side. So when you get 0m squared over s squared minus 900, so 900 minus the 0, you end up with just 900. So I'm just going to actually exit that and give you 900 meters squared over second squared, which equals 16 meters per second squared times D. Okay, so that's all over there. we divided it over, so it was negative because we minus the 900 over. I'm so sorry, my dog is running around like a crazy person. Okay, anyway. Okay, so anyway, he's having a Zoomy, you know dogs. Okay, I'm gonna rewind because I got distracted. I'm so sorry. Rewind, okay. Oh man, I'm so sorry. Okay, we're gonna minus, I lost my train of thought, minus the 900 over to this side, so you get 0 meters per second squared minus 900 meters per second squared, and you're gonna equal negative 16 meters per second squared d. So now that we have negative over here, and now we're going to end up with a negative on this side, because 0 minus 900, we get minus 900 meters per second squared equals minus 16 meters per second squared. You're going to also with the d, because it's still multiplying the d here, and then you're going to divide the minus 16 meters per second squared, divide this as well. Okay, and then your answer that you will get is 56.3 meters. After once you divide it over and you isolate it for d, so that makes sense there. So let me know if you are still having trouble getting up to this point, but that's one of the examples. Now I'm going to explain one more example using that step-to-step procedure, okay? Oh, I forgot to say, the last step was double checking if the answer makes sense and if it's reasonable, okay? The value does seem reasonable enough. It takes a car a considerable distance to skid from 30 meters per second to a stop. So the calculated distance is approximately 1/2 of a football field, making this very reasonable as a skidding distance. So checking for accuracy involves substituting that calculated value back into the equation for displacement and ensuring that the left side of the equation is equal to the right side of the equation, which it indeed does. So let's go on to problem number 2. So problem number 2, Ed is waiting at a stoplight. When it finally turns green, Ed accelerated from rest to a rate of 6 meters per second squared for a time of 4.1 seconds. Determine the displacement of Ben's car during this time period. Okay, so once more, the solution to this problem begins by the construction of a very informative diagram. Okay, so let's physically show it out so you know what's going on, okay? So let's draw out these cars again, which mine look like sombreros. Another sombrero to show where that car ended up. Okay, so I draw my diagram. I'm going to place out what we know, okay, what was given. So we know that time equals 4.10 seconds. The acceleration is 6.0 meters per second squared. And now we want to know the distance. The distance is equal to, we don't know. However, the car, when it first started, it was waiting at a stoplight. So that means you know the initial velocity of the car was 0 meters per second. Okay? Determine the displacement. So again, the displacement is the unknown variable that we are looking for. So we're trying to find d. So now that we know what's our unknown variable and our known variables, let's go and check out the kinematic equation. So the next step is look for that equation in which you can fit these unknown variables and variables. So we're going to go back to our equations. Okay, I'm just going to erase some of these x's here. Okay, so we know that we have time. We also have distance, and we also have the initial velocity that was given. So which formula can we use? Well, we have time, and we have initial velocity. We don't have final velocity, so that cancels out all three bottom ones, okay, because we don't have final velocity to use in the equation to solve for distance. So that means we have to use, ding, 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 the top one. So we're going to slide it over now. Okay, so we're going to use the top equation. D equals initial velocity times t. I like to sometimes identify my times as a star so you don't get confused with an x, because sometimes I use my x's to show different variables. But here, this is a multiplication, okay? So it's initial velocity times t plus 1 over 2 times a, so acceleration, times time squared. So now that we identified the equation and we have it written down, the next step of the strategy involves substituting known values into the equation and using proper algebraic steps to solve for the unknown information. This information I will show you right now. So we're going to plug in all those numbers that we got here into down here. Alrighty. So D is what we're looking for, entering our initial velocity of 0 meters per second, and it's times 4.1 seconds, which was all given, plus the, I'm going to change the 1.5 into a 0.5 times the acceleration of 6 meters per second squared, times by 4.10 seconds, and that is also squared. Now, D equals 0 meters, okay, plus 0.5 times 6 meters per second squared, and then we have times 16.81 s squared. So we have applied the square to the 4.1 here, and then we have also multiplied these two values together, and that's how we got 0 meters here. And now we have to calculate this amount and then add it to the 0, and your 0 meters plus 50.43 meters, distance equals 50.4 meters. I just rounded down. So that's how you solve this equation here. So the solution reveals that the car has traveled a distance of 50.4 meters. So I did round it down. So the last step of the problem-solving strategy, we have to check the answer to make sure it is reasonable and accurate. So the value does seem reasonable enough, and the car has accelerated 6 meters per second square and will reach a speed of approximately 24 meters per squared in 4.1 seconds. So this distance that we found, 50.4 meters, is very reasonable. Okay, so we did good. Good job, everyone. The next video, I am going to show you how to apply these strategies to free fall questions, and that's using gravity, okay? So have a good day, and I'll see you in the next video very soon.